We consider our professional team to be the Buckeyes usually. Plug in my neck of the woods, so that orange and brown team, it's not so great. We keep hiring or keep bringing in a very small quarterback, so it's pretty interesting. Business intelligence, for those of you that didn't know, this is the definition from Gartner.
We're hear him on the bridge. He needs to speak up.
They're a pretty reputable source. Here, I can sit closer to the mic if that helps. So it's kind of an umbrella term for applications. Their definition, they're including the infrastructure, the tools, and best practices that are used with a focus on optimizing decisions and performance of an organization. So business is kind of a broader term. What they really mean is an organization. So it doesn't necessarily have to be somebody that sells widgets and makes money off of it. Business intelligence can be used by any organization, whether they're public sector, Department of Defense, any. So hit the next. Yes, sir. My definition of it is slightly different. It's actually a subset of capabilities within a broader domain, which would be that data and artificial intelligence. So I'll talk a little bit more about what that's inclusive of, but this is a subset that's specifically focused on answering organizational questions and driving improvement processes, and this is typically done through the enhancement of data. So there's plenty of ways to enhance data, and we'll kind of talk through those, but this is how I like to define business intelligence as it stands today. I mentioned data and AI. What is that? So this is a newer term for a broader set of categories. You may have heard business intelligence, data analytics, data warehousing, decision support systems is one of my favorite terms for what we do. A data warehouse, you think of a factory somewhere where they're just large drives and volumes of information that's just being stored somewhere in a factory. That's not necessarily the case. A decision support system is more realistic. It's a collection of a bunch of different computer systems that are harnessing that data and are used for supporting decisions within an organization. That term, decision support system, can refer to a collection of some of the back-end components of a business intelligence solution. So if you have operational data stores, data marts, data warehouses, all of these things combined, all of them together could make up a decision support system. So that's a broader category. Additionally, there's all these other terms. So if you see things, performance optimization, reporting, and dashboards, that's what people typically think of business intelligence. They think of reports and dashboards, and we'll sure show you examples of some of those. But this is a very, very broad category. And then lastly, there's even more. So there's a lot of technology sets that are used in being a business intelligence professional, and you have to be aware of all of these different terms and categories and what they mean. If I went through this entire list and spoke to all of them, I could probably go 20 minutes to a half an hour on each, which is far too long for this type of session, but we may in the future have additional types of sessions like this where we'll dive into more specific categories underneath this umbrella for your general knowledge. The next important question is, what is business intelligence not? It can be very confusing when you see reports and you see dashboards that are the output of business intelligence, to confuse those with the process that they support. Those processes are not, they're not business intelligence. They are supported by business intelligence, but the workflows themselves, data entry is not a business intelligence process. It's what feeds a business intelligence process. So you would do data entry into a system of record or some type of transactional system, and then business intelligence and all of the other data and AI capabilities will help pull that information out of those systems. So it is not, business intelligence is not a system of record. It's not just reports and dashboards. There are a number of processes if we look at how we build those. It's not a spreadsheet repository, so this happens in a lot of organizations. they'll have a lot of spreadsheets with information, and they'll just keep building what we refer to as a spread mart, or a data mart of spreadsheets. That's really, really hard to manage. There's more effective tools and ways to do that. Business intelligence is not just SharePoint. SharePoint can be used to showcase business intelligence features, but SharePoint itself is not a business intelligence platform or tool. And it's not Dynamics 365. So for those that have had experience with Dynamics 365 and CRM, it's a little bit different than business intelligence. So that's used more for a lot of the workflows and process and entry points of data, as opposed to bringing data back out and making actionable decisions out of that information. Go to the next one. What do organizations want from data? Primarily, they want to run their business. They want to run the mission without interruption. So that's a primary use of data and information systems. But very quickly, once they're putting information in, they want to get it back out, and they want to see it in charts. They want to visualize it. They want to be able to make sense of the information that they have available. And they do that typically through charts, graphs, diagrams. Some tools will even create cartoons out of information. So when you look at publications like the Wall Street Journal or USA Today, you'll see information graphics. All of that is a different type of visualization. So they can come in many different forms. And there are actually tools that will then take those animations and then turn them back into text. So for the people that can't understand what a pie chart or a bar chart or a line graph is showing them, there are tools that will take that information and turn it back into text to explain what the chart is trying to showcase. So the next one. So here's an example of everybody's favorite pie chart. This is one way to represent data so that you know what elements are what. The yellow obviously resembles Pac-Man. The blue doesn't resemble Pac-Man. That's its mouth. And then the red ribbon is Miss Pac-Man. So the next one. Here's a line chart here. You don't really have any context in this visualization, but you can kind of see, just based on the way that the lines are going, that depending on that context, it's either good or bad to either be a bear or a dolphin. I mean, if this is how many are left, it could be good. If this is how many anticipated births, it could go the other way. So you have to have the right context of visualizations in order to be able to understand the visualization itself. The next one. These visualizations are advancing dramatically over time. We used to just have the pie charts and the bar charts. Now we have a lot more integrated mapping and location and spatial data. So we're able to combine some of these bar charts with some of these mapping visualizations to show far more useful and visually appealing data points. And then this last one is a visualization of a neural network. It's a little bit of an eye chart and probably something that's difficult to see, but for those who are really getting into causal values or items that may have caused one turn of events based off of a number of predecessors, this is a very interesting way to visualize that type of information. Where does the data come from? So, the next one. Organizations today, a lot of the data is being pumped through applications, and underneath those different applications are different sets of databases. This is a graphic with some of the more common databases that are in use today. Oracle is obviously a very large one. Microsoft SQL Server is another database that's very prevalent. MySQL. So all of these different databases can create a little bit of a headache. Most organizations use a lot of these. If there's any COTS software or GOTS software that's been acquired by an organization or a group to perform a specific function, they could have a different type of database that underlies it that is using one of these different flavors. So when I want to get information back out, get the next one, what you end up with is just a lot of information that's tangled. So how do I make cohesive use of information that may be in different flavors of databases and applications? It can be kind of difficult to do. So how does all that work? So if I have all of these disparate systems using different databases, I need something to be able to pull this back out so that I can collaborate and show other people the information that I've gained. So you have all the different data sources that you can start with, and the ultimate goal is to be able to share this much in the way the presentation is being shared today is through SharePoint. It's something that's accessible to most organizations. I can't remember the last time I was somewhere where they didn't have a SharePoint site to be able to use for sharing and collaborating documents and information. So hit the next piece. What we have in place in USARC is what's referred to as a business intelligence platform. This is a combination of a number of components within the Microsoft business intelligence stack of products. At the lowest level is SQL integration services. This is what we refer to as an ETL tool, or an extraction, transformation, and loading tool. Integration services will pull this information, so if you hit the next button, it'll pull information from any of these sources and then further up into each of the products. So it'll pull data into a relational database and SQL Server, and then that information kind of floats up through the other components, whether they be analysis services for a multidimensional cube or reporting services if it's just a report. And then all of that content can then be shared through the SharePoint platform. So these different buckets, the way they work in USARC today, integration services is the tool that we use to manage the data orchestration from the source systems. We're pulling information from Active Directory, from SCCM, flat files, SharePoint lists, Excel files, CSV outputs from other systems. It really could be anything. Integration services has a robust set of capabilities to be able to pull electronic information out of those sources and then into a database that we manage and control. A data mart is another interesting topic on this slide. I had this kind of in one of our earlier slides as one of the things that we use. So we refer to the information that we've reshaped and organized within USARC as a data mart because it's siloed based off of one subject area. So most of the information that we use is sourced through the G6. It's information that's pertaining to devices, computers, switches, routers, all of the components that the G6 is responsible to manage and we'd be using for reports or dashboards, something that they would want to have visibility to. That doesn't necessarily mean that that's the only thing that could be done, but in this existing instance, that's primarily what we're focused on. So that's the difference typically between a data warehouse and a data mart. A data warehouse is something organizationally that's typically an enterprise solution, whereas a data mart is something that's usually a functional or a departmental solution. Analysis services is a multi-dimensional database server. That's also another topic that we will probably share in a future session. The best way to look at that is it surfaces the data through a semantic model, which is a representation of information that is easier to handle than what's surfaced in a relational database. So not columns and rows, but something that's based more on the entities that you're used to seeing. So if I'm looking at organizational hierarchy, the Army has one, I can model a multi-dimensional database to mirror that organizational hierarchy so that when I want to view information at a battalion level or a division level or a unit level, I can easily drill up and down that hierarchy instead of having to know how to go grab that information from columns and rows that are in a database table. And then at the top, the SharePoint server platform assists business intelligence by being able to showcase reports that have been created with the reporting services tool, dashboards, Excel workbooks, basically any content that you can create. That's what SharePoint's strong point is. It's a house for retaining and sharing all the information from anyone within the organization. Next slide there. So how do I build this? So Microsoft isn't the only solution for building BI. This space gets larger and larger every year. Cognos, MicroStrategy, Oracle, SAP. There's a lot of different tools that do business intelligence. So if you see other tools and in your dealings with other people, these are some of those names that you might see that people would refer to as business intelligence. But in USARC, we use the Microsoft tool set. So the most popular tool for business intelligence on the planet has been so for the last 25 years running. Anybody have a guess of what that might be? The next. It's Excel. So Excel's been doing this for a really, really long time. Most people are probably familiar with Excel pivot tables or just Excel tables. You can create visualizations, line charts, bar charts, graphs, anything you want in Excel, and have been able to for a long time. Properly constructed, Excel is a very, very, very powerful BI tool. It's used for enterprise organizational solutions, department solutions, personal solutions for people just doing discovery of information. If they're looking through a large SharePoint list and they just want a simple chart, it's easy to pull that into Excel and make a pie chart or a bar chart. The reason why it's been so successful and why most organizations gravitate towards it is because of its simplicity. It's intuitive, people know how to use it, and in all of these other business intelligence tools, the number one feature in each one of those tools is the export to Excel function. So however they're doing it, whatever the software does, the first thing users usually do is hit export to Excel because that's what they're comfortable with. Right after the run button on the report. So go ahead and hit the next one. So the other tool we use primarily within USARC is reporting services. Reporting services is Microsoft's production reporting tool. So this is a more developer-heavy tool. It uses Visual Studio to develop this. So this is typically something that an IT professional would use to build reports or dashboards. And then the last tool that we use is a tool called Power BI, and specifically within the command we use a tool called Power BI Desktop. This is something that's available to anyone within the organization to be able to download and start looking at information in Excel files or access databases or any other database that may be able to surface information and start visualizing and displaying business intelligence components. Let's hit the next. So there are a lot of different tools within Microsoft's business intelligence suite. So we have a lot of different components of software, and they have sweet spots in what they do and what they do well. And you can kind of see the way this chart is organized. There's a difference between things that have typically been IT authored or people who are professionals at business intelligence and have experience, versus just a business user or an end user who wants to just look out, find some information, and create a visualization that they may share within their team or unit or group. And then there's different ways of looking at information. So at the bottom, this arrow shows the difference between free-form data exploration and more structured data analysis. So free-form data exploration is going to be...
Excuse me, sir. If you have your mic on, please mute it. You're hearing an echo back from our A-band. Thank you.
Free-form data exploration is commonly referred to as self-service business intelligence. So there's a set of information. I want to go look at it. I want to use tools that I have access to it, and I want to be able to just dive in and look at whatever I want to and come up with whatever conclusions I can derive. We have very specific tools, and I mentioned Excel is very good at that before, which is why it's the most popular tool on the planet. Power BI is one of those tools that would be also very, very good at kind of free-form data exploration. It's very intuitive and easy to put information into that tool and then to start building a chart or some type of visualization that helps build the story of whatever you're trying to showcase. Reporting services that I had mentioned before is much better at guided data navigation, and we'll take a look at some of the reports that we use USARC for, that kind of guided navigation and guided structure. Structured analysis is the data exists. I have a model of information that I can go get, so I'm not constrained by tools, I'm not constrained by having to go fish for the information that I want. It's all available, but it's not telling me how I have to visualize it. I can use that model and kind of do my own exploration, but in a very rigid way. So this I may not have to clean information or add organizational hierarchy elements to it. Those are all available to me already. I just have to pick and choose the components that I want and put them in whatever report or dashboard that I see fit. And then lastly, spatial data analysis. We saw one of those mapping charts. This is becoming more prevalent in a lot of tools. Power BI tackles this. Reporting services also does mapping. And then other non-mapping but more schematic visualizations can be done with Visio services, and even Bing Maps has a lot of those as well. So that's kind of the lay of the land of the tools that we use and what we use them for. So next. We saw that data platform with integration services and all the different data sources a little earlier. This representation on the left is kind of how we look at that. That's what we would consider traditional BI. That's how the BI team here at USARC does the reports that they do. We have about 250 reporting services reports that have been generated, and they've all been done largely with this traditional BI process. So what we've done is take files and information. We go through a data quality process that allows us to kind of marry pieces of information from varying systems and determine what is correct, what is the point of truth in the information, and there's a lot of business rules that go into processing and disseminating that information. This traditional process is typically done by IT professionals or people that have experience like myself to do this type of work, but it can be very time consuming. So that quality of information that's being disseminated in those reports, there was a lot of effort that was put into it so that you can trust that information. In some cases, that may not be what you're looking for. You're looking for quick information. The quality of the data may not be something that you're concerned about. You want a fast answer to a question, where are these widgets? How do I get to them? I'm going to, sort and reshuffle them and get rid of them. So this is something I don't want to spend a whole lot of time on. It's not something I'm going to be looking at for the next year. Those are typically more self-service business intelligence types of solutions. Power BI and Excel are are very good at creating those, and that's what kind of helps break through that wall of, these are things that IT professionals do versus these are things that an end user can do very easily. What do we do here? So these are a couple of examples of the reports, and I'll kind of run through these quickly, but these are some of the visualizations that we've built for readiness, for LOE tracking. You can hit the next slide. And these different visualizations were built both with the reporting services tool as well as the Power BI desktop tool. So there isn't one particular tool that needs to be used for building a dashboard or versus a report. Any tool can be used to build a dashboard. It's not one does one or the other, but they have different feature sets and capabilities that make one better in certain situations than another. And some of that, a lot of that typically just has to do with what the end user is going to do with the information. If it's something they're going to print, reporting services is very, very good at doing pixel perfect formatting. So if it's something that needs to be displayed repeatedly or needs to be exported into a portable format like PDF or a Word document, reporting services is really good at that. Something that might be something that's more throwaway or just free-form data exploration, Power BI desktop and Excel are very, very good at that particular function. So here's some more examples of mashing some of those geospatial visualizations with calendaring. So there's a lot that can be done visually with these business intelligence tools. Get the next one. They can be straight color-coded reports, so we use these for some of the STIG auditing within the G6, but a lot of different types, pie charts combined with bar charts, and a lot of these reports are also interactive. They allow you to drill down to further information, so if I see something at a higher level that may be red, I can click on that item and go deeper to understand why is that item red. Is this something I need to take action on, which is typically a function of business intelligence. And then this is just another set, just showing some of the visualizations that can be created. They don't all have to be tables and charts and rows. They could be pictures of different things. Line visualizations, indicators that show trending. So a lot of the value that you get when you go through a more traditional business intelligence design approach is that ability to create trend analysis. That's something that's very difficult in everyday spreadsheets or databases to determine. Usually requires storing historical information and then gathering that for a long period of time before you can see how did something perform a month ago, how is it performing today. It's costlier to do that, but there is a benefit for managing that volume of information. And then just a few more visualizations that can show geography and status. So typically we want more than visualizations. At the next. These visualizations and most of what's been used to this point in time is descriptive, what happened, or real time if it's really good. So if we throw more resources at a particular solution, we can get much quicker to how is this actually occurring right now, and we can see the information and make decisions based off of what's happening now. The next piece. What organizations want now is a step beyond that. Visualizations are great. They tell us what's happening. They're not telling us what we should be doing. So business intelligence isn't just show me information and show me it in pretty pictures. It's, well, why did this happen? So there's an underlying answer to different questions inside the data, and there's a little bit of science in extracting this information from data. Predictive is what can happen. So let's say these two events have occurred, I've tracked that information, can I predict what's going to happen in the future? There's a lot of use to that type of analysis. And prescriptive, what do we do? So in the event that X and Y happened, what Z, measures should we take to remedy that? If it was an issue or if it was good, what are the action points after that? This is what we would typically refer to as getting into artificial intelligence. So taking the information and then making a system or a solution that can act upon data that's come into it. So we hit the next, and basically this is the future. So this is where a lot of time and effort and money is going within the industry and the organizations, is moving past business intelligence and into artificial intelligence. Next. How will this work tomorrow? There's new challenges in the data environment. So we saw those different types of databases before. It's a pretty exhaustive list of the different types of relational databases that will underlie applications. But this has become more complex with the advent of things like social media, big data, semi-structured data. The next slide. So that really speaks to what's called IoT, or the Internet of Things. These are Twitter feeds, Facebook posts. There's just a wealth of information that is now out in the world that can be cataloged and categorized. So think of the Minority Report. We're entering into that phase of human existence where data and information is flowing all the time through different sensors, feeds, very large systems, and it's not stored the same way as typical applications used to in the past. So the next slide. An example of this would be documents. So SharePoint collects documents, but documents don't necessarily mean a piece of paper like Walter has here. So this could be a document could be something electronic that isn't formatted necessarily like all other sets of data, but it's loosely formatted. So I can still pull it into a business intelligence system, make sense of some of the information, and then other components are thrown away. And then click again. Big data speaks to this last issue. The data is expanding just at massive speeds because of the ability to store things that have great variety, like semi-formatted, the velocity, things like Facebook posts or Twitter feeds. If you've ever posted something political on of someone's Facebook page, every one of those entries, because there will easily be 30 within 5 minutes, each one of those is another entry somewhere in some database. The velocity of how quickly people are responding and creating all of this electronic information is just beyond what anyone ever envisioned. So this volume of data that's being created, the velocity in which it's happening, if somebody posts something on Twitter and 100,000 retweets happen, that's just incredible data volume that's occurring. So how do we handle that? In the past, we would put those into what would typically be called a SQL database, which are simple relational databases, not to be confused with SQL Server, which is the name of a Microsoft database, but a SQL-oriented database. That can't happen with these big data elements. It's just not fast enough to perform that. So we use what are called NoSQL databases. The next slide. I'm confused. SQL, NoSQL, what's the difference? Click again, and one more time. So there are two prevailing database types. One, a SQL or a relational database. This is what banks would use. This is what line of business systems use. This is a transaction, something that I need to be sure this went in. So if I get to the guard desk and they're checking me out in JPAS is running on a relational database. They need to know who I am, what my information is, and it doesn't match the ID in order for me to get into this building. So that type of information needs to be consistent. It needs to be rigid. It needs to be stored in a relational database that performs that function. If I had 100,000 people who are all trying to come in at once, we'd need more guards. But you'd need a system that was able to handle that type of volume. That's something that a NoSQL or a more base type of database system could handle. It's things like Facebook, Twitter, those run on those base type of systems. And that means basically available, soft state, eventually consistent. If you've ever posted something on Facebook and then maybe gone back 30 minutes later and noticed that comment was gone, but then you go back in an hour later and it's back again. It may not have been replicated to all of the different partitions within that NoSQL database. So that's what they mean by eventually consistent. 3 days later, is that entire comment thread back? Yes, it's eventually gone through all of its processes and made it everywhere it needs to be tracked for good. Would that work at the guard desk with the system that they use to let you in the building? Probably not. You'd have a lot of people very upset that they sometimes could get in and sometimes not. It would make it very hard to be able to go to lunch. So the next one. And the lesson here is, if you only have a hammer, everything is a nail. So that isn't true anymore in these data systems. There are different tools for different use cases. The next one. So with that big data, this is really expanded. So this is definitely an eye chart. This was as of 2 years ago, so this doesn't even include all the different products and tool sets that have been created since 2016. But you can see that there's a lot going on here. There's cognitive analytics, speech analytics, business intelligence, and artificial intelligence has made this entire landscape very, very large. So the next slide. It's a lot to deal with. It's a lot to understand what all these tools do, what they're good at, which product I should be using for what. Get to the next one. But that's okay. A lot of this, you think if I was going to install all of that within an organization, I'm going to need 1,000 servers to just sitting around to be able to use all the information or systems that are available. How other organizations are doing this very typically is using the cloud to perform this type of analysis. All these things, you can keep clicking through here, all these things that we talked about before, this data and artificial intelligence type of workloads, the cloud has solutions for each one of these. So put all the ones in the bottom as well. Things like the Azure Data Warehouse, machine learning. These are all cloud services that do each one of those specific capabilities. Put the next slide here, and then build out. There should be 3 more. The cloud does all of these processes through one of the 3 kind of pillars of what the cloud is. So whether it's software as a service, something that's already running out in that ecosystem that I can just subscribe to and take advantage of. It may be a platform as a service, something that I can code against in the cloud, but I don't have to start from scratch, or I can actually use infrastructure as a service and just create a new computer on the fly and then put whatever system or software I need to on my computer. So there are different ways of doing that. The next. Microsoft, as with everything, it has its own set of tools that do this. Theirs is called the Cortana Analytics suite. It does all of these different big data and business intelligence types of processes, but it does it without having to maintain any of this in a data center within an organization. So it's streamlined and makes effective use of cloud resources. The next one. So who's able to do this stuff? Slide. You would think maybe Wizard, and maybe this guy. It's really a data scientist, but is that what a data scientist is? Not really. Close, but not exactly. So next slide. A data scientist is somebody who typically is pretty good with math and statistics, and also has the ability to take information, put it into visualizations. This is the BI team here at USARC. This is what we do with the next couple of here. Math and statistics is typically school and training. Domain knowledge and soft skills. This is just being passionate about building this type of information. So if this is something that excites you and you're passionate about, it's pretty easy to learn if you're excited about it. If not, just sit back, look at the cool stuff, and hopefully we'll be able to build you cool cartoons that show you what's going on in the future. The programming portion of this and understanding all of those different technology sets that are being used, it really is just about interest. It's about being interested in what those do, what they're good at. That's kind of the nerdy part. And then the last part is the ability to tell a story, which is really what business intelligence is about. Tell me what's happening. Tell me what I should do. That's kind of the goal. So how do I engage with the BI team here? So we have a full-time team here that does support for these types of projects for USARC. Off of the BI Center page, there is a link at the bottom to request a solution. So if you have something organizationally where you want a business intelligence solution created or some process to be tracked or improved upon, we can help you do that. There's just a couple of questions that need to be answered off of that form, and then that'll go through our process and let us know how we can start to help you. So if business intelligence is interesting to you, we do have more classes coming up. There'll be training Tuesday through Thursday next week at the training center. This will be Power BI training. So we talked about that Power BI desktop tool that we use. This builds dashboards, mapping visualizations. It's one of the free-form exploration tools. So you won't have to write any code or build any databases. This is more how do I build really cool, fancy stuff in some of our tools. Additionally, there is training online. The Microsoft tools that we use here at USARC, there is a program for data science. There is another one for big data as well. But these can be audited and they're free. They're all on the Academy website. This is an exploding field within technology and computers, so if it piques your interest, this training is very good. I've done these. They can be audited for free, so no cost. Very, very good training. And then the next one. And then lastly, there are other sites besides Academy. Linda, which is the online technical training component of LinkedIn. Pluralsight, edX, YouTube. So there are videos on how to build all these things, how to build pivot tables in Excel, how to build reports with Power BI Desktop. There's a lot available online. And then that's it. Any questions?
There was one question out in APAN while you were discussing earlier. I'm just going to ask it, maybe something you want to take back to him later, but the question was posed by Mr. Cloninger, can we be given access to Power Pivot as an add-on in the Excel so that Power Pivot galleries RSS feeds in SharePoint? At this point, they only have Power View as an available option.
No.
What's that? On some machines. So there is a group policy that does prevent the Power Pivot add-in, but that's something we can follow up and see what we can do as far as relieving that group policy.
Tenfold. Any other questions on the bridge from APAN? in the room? Comments, fears, hopes, confessions? I do see one person, two people typing down here. That was it. Thank you, sir, for speaking with us today. If you didn't have the opportunity to come today and you're listening and you know someone else needs to come, he will be doing this tomorrow at the same time, just one room over. 40 people. I lost my train of thought with that 40 people. That's how I do it. Anyway, we'll still be here for a few more minutes for any questions, but other than that, have a great day. Thank you all for coming, and adios.